2 implication and equivalence. We can use the notion of tautology to define two very important notions in sentential logic, the notion of implication, and the notion of equivalence, which are defined as follows. Formula logically implies formula B if and only if the conditional formula AB is a tautology. Formulas A and B are logically equivalent if and only if the biconditional formula AB is a tautology. Note the above definitions apply specifically to sentential logic. A more general definition is required for other branches of logic. Once we have a more general definition, it is customary to refer to the special cases as tautological implication and tautological equivalence. Let us illustrate these concepts with a few examples. To begin with, we note that whereas the formula P logically implies the formula P and Q, the converse is not true. That is, P and Q does not logically imply P. This can be shown by constructing truth tables for the associated pair of conditionals. In particular, the question whether P implies P and Q reduces to the question whether the formula P and Q is a tautology. The following is the truth table for this formula. P and Q F TTF TTTF TTTF FTF TTF FTTF TTF FF. Notice that the conditional P and Q is a tautology, so we conclude that its antecedent logically implies its consequent. That is, P logically implies P and Q. Considering the converse implication, the question whether P and Q logically implies P reduces to the question whether the conditional formula P and QP is a tautology. The truth table follows. P and Q PF TTTF TTTF FFF TTF FTTF TFFF TTF. The formula is false in the second case, so it is not a tautology. We conclude that its antecedent does not imply its consequent. That is, P and Q does not imply P. Next, we turn to logical equivalence. As our first example, we ask whether P and Q are logically equivalent. According to the definition of logical equivalence, this reduces to the question whether the biconditional formula P and Q is a tautology. Its truth table is given as follows. P and Q F TTTF TFF TTTF FFF TFTF TFF TFTF FF TTF FF TTF TTF. In this table, the truth value of the biconditional is shaded, whereas the constituents are marked by. Notice that the biconditional is false in cases 2 and 3, so it is not a tautology. We conclude that the two constituents P and Q are not logically equivalent. As our second example, we ask whether P and Q are logically equivalent. As before, this reduces to the question whether the biconditional formula P and Q is a tautology. Its truth table is given as follows. P and Q F TTTF TFF TTTF FTF TTTF TFF TTTF TF TTF FF TTF TTF. Once again, the biconditional is shaded, and the constituents are marked by. Comparing the two columns, we see they are the same in every case. Accordingly, the shaded column is true in every case, which is to say that the biconditional formula is a tautology. We conclude that the two constituents P and Q are logically equivalent. We conclude this section by citing a theorem about the relation between implication and equivalence. Formulas A and B are logically equivalent if and only if A logically implies B and B logically implies A. This follows from the fact that AB is logically equivalent to AB and BA, and the fact that two formulas A and B are tautologies if and only if the conjunction A and B is a tautology.